And what's happening in our data sphere, our data ecosystem, is a similar phenomenon with the data double spending. And so what I mean by that is the kinds of things that have been happening where individuals maybe agree to share their information, sign up for a service, to use an app, sign up with, for example, 23andMe to get our genetic biomarkers analyzed for purposes of tracing family history, whatever the example might be. And we are okay with sharing that information for that specific service, for that specific period of time that it's needed to complete that service. But of course, we all know what we're finding is that data is often kept, retained, and the acquirer of that data finds other ways to monetize it and use it for purposes that we oftentimes were not aware of. We never consented to it, and we don't benefit from it.
Okay, welcome back to the Pair Review. We are very excited to be joined here by Professor Victoria Lemieux and her master's student Meng Kang from University of British Columbia. Professor Lemieux is a professor at UBC, British Columbia. I might have said that already, but that's okay. She's head of the blockchain cluster, which is what drew our attention to this kind of work. And we're very excited to learn more about what they're working on and this paper that they've recently published in the Ledger Journal, which is a journal very dear to our heart, called A Decentralized Identity-Based Blockchain Solution for Privacy-Preserving Licensing of Individual Controlled Data to prevent unauthorized secondary data usage. So a lot of really important terms in there that I'm sure we're going to learn more about. So with that, I will give the floor to Professor Lemieux and Meng Kang. Thank you.
Thanks very much, Carlos, for that kind introduction, and thanks for having us here today. It's really great to meet you guys and to know about your work, which is really interesting, and the Pair Review. So yeah, I thought maybe I'd just start by sharing with your listeners a little bit more about what we're doing at the University of British Columbia with Blockchain at UBC. So Blockchain at UBC is the name we've given to our blockchain decentralized trust technologies research and education cluster, which was started in about 2017. And it started off with just a group of my students and I getting together and saying, hey, this blockchain is really interesting. Let's learn more about this. Let's just, start talking to people in our community in Vancouver, which is a really vibrant, decentralized community. Reach out, learn more, and start to educate ourselves about this. So it started really with a small band of really engaged and interested students. And we've now grown into a multidisciplinary research cluster, quite large, doing a very wide variety of research. And we were recently ranked #1 in Canada for blockchain education by CoinDesk and number 28 in the world. So we're proud of what we've grown into. We have a lot more to accomplish, but we're really pleased to be making a contribution to this space. So what we're here to talk about today is some of the research that Meng and I have done together recently. And it focuses on what I characterize as the data double spending problem. So what do I mean by data double spending? Well, everybody's familiar with how Bitcoin solved the digital money double spending problem. So, the way that Bitcoin is configured, and specifically the use of blockchain technology and proof of work consensus mechanism, cryptographic hash linking, and so on, prevented digital money from being spent twice. So it prevented me from sending you, Carlos, money and sending the same money to somebody else, and it being spent before you could spend it. Is essentially what that boils down to in really simplistic terms. And what's happening in our data sphere, our data ecosystem, is a similar phenomenon with the data double spending. And so what I mean by that is the kinds of things that have been happening where individuals maybe agree to share their information, sign up for a service, to use an app, sign up with, for example, 23andMe to get our genetic biomarkers analyzed for purposes of tracing family history, whatever the example might be. And we are okay with sharing that information for that specific service, for that specific period of time that it's needed to complete that service. But of course, we all know what we're finding is that that data is often kept, retained, and the acquirer of that data finds other ways to monetize it and use it for purposes that we oftentimes were not aware of. We never consented to it, and we don't benefit from it. So again, we can point to things like the Cambridge Analytica scandal of a couple of years ago. 23andMe was able to monetize the data that they had acquired from their customers by selling a large stake of their business to GlaxoSmithKline, a pharmaceutical company that was using that data to investigate, to conduct research for new drug therapies. And there's nothing wrong with that per se. It's a good thing to develop new therapies. However, I don't think it should be done without the knowledge and consent, and in some way benefiting the individual whose data contributed to the pool of data that is being used for this research. So I just think that there needs to be more fairness and transparency and accountability in the data ecosystem, and that individuals' privacy there need to be better tools to protect individuals' privacy and their ability to maintain control over their own data. So that's really what motivates our research here. And I really felt that within the research that was being done, even in personalized blockchain-based healthcare, even within self-sovereign identity-based blockchain solution research space, or if we're talking privacy preserving, differential privacy, all of these different techniques, there was a gap in that the primary protecting individuals' privacy in the context of the primary use of their data and getting individuals' initial consent was, there was a lot of focus and attention on that, but not so much a focus and attention on how do we prevent this unauthorized secondary use of data, or as I characterize it, the data double spend. And I felt there was a gap in the research, and that's where I wanted to point my research in the direction of. So that's where Meng comes in with all of the great work that he's done, as he's made this the focus of his master's research, which he happily defended and has now passed and achieved his master's, and he's out there now looking to make his contribution in the world. So Meng, over to you.
Okay, and the content of this presentation is mainly based on my master defense, and I mean, there is a need for solutions that give the individuals greater control over the usage of their personal data with trust and in a privacy preserving manner that prevents this kind of unauthorized secondary use. And in parallel, the application of blockchain and distributed ledger technology to enforcement of data usage policies aimed at preventing unauthorized secondary usage still has not been fully researched. And the self-sovereign identity systems are novel blockchain-based solutions which shift the control of data records from organizations to individuals. But most SIS solution designs are used almost exclusively for identity or authentication. And figure 2 shows this kind of a conventional use case. For example, in this model, there are 3 roles: the issuer, holder, and the verifier. For example, The issuer could be government. It issues you a piece of digital ID, and you can keep this piece of ID in your digital wallet, and you can present to this ID when being required. I mean, for a bank and or a university, and so as a system, we have the control. I have the potential to provide individuals with control over a much broader range of personal data, and it has a capability that it can be used to address the issue, the data double spending issue we raised above. And so there are a lot of related work has been done in this area, and solution based on decentralized identity blockchains have received the attention of some researchers, but existing solutions do not take into account that SSI can be used to build such a system for shared personal data, permits limited access to third parties under particular conditions. Also, they do not address the problem of preventing the unauthorized use of data after the identity or other data have been shared. And here are the objectives of this study. This study aims to combine and build upon the previously research from the fields of identity management, confidential computing, and data usage control to provide a novel design and implementation of a fully decentralized and a privacy-preserving usage control enforcement infrastructure that overcomes the limitation of a centralized data usage control, where in formulation of the data usage policies, licensing and the subsequent data usage is under the control of the individual data subject. And the data subject receives compensation for the use of their data, and the secondary use of the data that has not been authorized by the data subject is prevented. So the next section is the decentralized identity-based blockchain solution. So before diving into my solution, there are some necessary knowledge to be introduced first. And in the area of identity management, this solution is aligned with emerging decentralized identity standards, the decentralized identifiers, the data communication, and the verifiable credentials. And in respect to confidential computing, this CKK's fully homomorphic encryption scheme is incorporated with the system to protect the privacy of the individual's data and prevent unauthorized secondary use when being shared with potential users. And in the area of advanced data usage control, my solution leverages the conventional digital rights management system architecture to derive a novel individual-centered approach for licensing of data usage. But here is the question, why this kind of decentralization is so important? And this question can be answered by the evolutionary progression of internet identity models. As figure 3 shows, this is a very conventional, a centralized account-based model, which is the original form of the digital identity. And for example, you can register your account with Google and Facebook, but in this case, the ownership of your account and your identity, your data is not you. The organization can delete and to send this kind of data to a third party without your knowledge. And the figure 4 shows a federated identity model. This is developed by the industry to alleviate the pain points of the previous one by inserting identity provider. And but in this case, you still have a man in the middle and identity provider. You need to be trust. And if the identity providers do the same thing as the organization, this model will fail. And for example, you can use such as some federated protocol of I mean, the OAuth protocol, you can use your Google account or Facebook account or GitHub account to log into some third-party websites. And the figure file is the most important, I mean, the most cutting edge decentralized identity model used in my solution. And the most important difference is this model is not account-based. It works like identity in the real world. And it based on a directly relationship between you and other peers. And you both share a connection. So, and as the decentralized identity model started to catch on, it quickly developed the moniker self-sovereign identity. And the figure 6 show how it works. There are 3 roles in this model: the issuer, holder, and the verifier. The issuer signs and issues the credential to the holder, and the holder keeps this credential in the wallet and presents the proof when the verifier is requesting this information. And the proofs could contain information from different credentials, and it can not, and the proof cannot not be the real informations, and they can use some cryptography techniques such as zero knowledge proof. And the stack leverages agents, which are software represented and controlled by the identity in the real world. The agents utilize the secure peer-to-peer connection to communicate. And this SSI is powered by a blockchain. So when an issuer issues, when the issuer issues a credential, the issuer creates a decentralized identifier associated with their public key and an address that can be used to contact themselves into the blockchain. And when a verifier receives this piece of proof presentation from the holder, they will be able to query the blockchain to find out who issues this piece information, if the information is altered or changed, and if the information is still valid. And then there is another technique to be introduced, is a fully homomorphic encryption. This allows computation on encrypted data while preserving the features and the format of the plain text. The CKKS FHA scheme is the most effective method of performing approximate homomorphic computations over the real and complex numbers used in this paper. And here comes to the overview from my design. The design of the process is inspired and derived from a conventional digital right management system, but built in the SSS stack. So there are 5 roles in this solution. The individual is a person who is owner of their data, and the consumer is a person who requires a limited use of individual data under authorized conditions. The data issuer is the issuer of the individual's data credentials. The distributor is who issues license credentials to consumers. And the data manager is who keeps individuals' data securely and authorizes the consumer to access the data. And this figure shows how it works. The data is issued to the individual by means of variable credentials, and the data is encrypted by a layer of AES encryption, as well as a fully homomorphic encryption. The data owner shares data by presenting a proof to the data manager. The data manager stores this piece of encrypted data in the cloud and then issues a storage credential with the access token of this data. The individual sets up the data license for the distributor. The consumer purchases the data license with the distributor. And only after verifying the license credential, the individual will provide consumer with the whole token used to access the data and the key used to decrypt the data in a verifiable credential manner. And for ease of presenting the design, architecture is divided into two parts. First, this figure shows the data sharing and the storage architecture is presented first. This includes the interaction between the data issuer, the individual, and the data manager. And in this decentralized architecture, actually there can be multiple instances of each role. I mean, multiple participating issuers, individuals, distributor and data managers, and the consumers. And this algorithm shows the process of data sharing and storage. And secondly, the data licensing and the consumption architecture in here. And this algorithm shows how the license is distributed, how the payment has been made, and how the license is verified, and how the access token has been shared. So, and in this implementation, we use the Python Iris Cloud Agent and the BC Verifiable Organization Network as a blockchain ledger. And all these cloud agents and apps are developed in form of Docker containers. And I leveraged the Tensio library for doing homomorphic encryption operations on the tensors. And this figure 11 shows an example of network communication architecture between a distributor app and consumer app. They have encrypted peer-to-peer connection, and there are controller which defines the business logic to control the agent to send verifiable credentials and send proofs and sending messages. And the third section is the functional evaluation of the solution. And the technical and the workflow functionality of this implementation based on a scenario in which an individual owner of health data licenses the data for use, health researcher is evaluated. And the data held by individuals is based on the data available in the molecular taxonomy of breast cancer international consortium dataset. And this figure shows the health data credential issued by the issuer and the storage credential issued by the data manager in the individual's digital wallet. And this credential includes all the necessary information related to the individual. And as you can see, there is an AES-key to decrypt this piece of data. And this is a payload of data. And in the storage credential, there is an access URL, which is a token based on the AWS S3 to access this piece of data. And this URL could be shared with a consumer when permitted. And so we can move to the second one is a license credential. And the license credential is stored in MongoDB we simulated, and it's issued by the distributor after the payment has been made. And this credential includes all the necessary information related to purchasing the data. And it is worth noting that the payment method attribute in this case is a cryptocurrency method called Tether USD, which is a kind of stablecoin and packed with the US dollar. And this one is confirmed transaction on the Tron network blockchain. And then this figure shows the license proof presentation received by the individual from the consumer. And this one is a storage proof presentation received by the consumer, which contains the requested attributes from both the previously storage credential and health static credential owned by the individual. So at this time, the consumer could access the stored data by the access URL and decrypt this data with the AES key. And the data held by individuals is based on the Metabrick data sets. The consumer got access to the encrypted data on performing the computation on the data. And the performance of using logistic regression on the plain text and the encrypted data shows the comparable results. And so in this section, the functionalities of design evaluated. It proves the feasibility, but it also shows that using homomorphic encryption to protect the data privacy still consumes a lot of computational resources, and which remains as an open question in broader applications. It takes around 3 minutes doing homomorphic encryption computation on the plain text, but on the encrypted data, it's around 100 minutes. And so here are the conclusion of future work. To conclude this study, oh, sorry, I just put this thesis here because this is based on my graduation thesis presentation. This study presents a novel design and implementation that incorporates decentralized identity-based blockchain solution to enable licensing, sharing, storage, and consumption of individually owned and controlled data. And my design provides individuals with considerably greater control over a much broader range of personal data compared to the conventional application scenarios of SSI. And it expands the applicability of blockchain-based decentralized identity. And the novelty of this study is also in the perspective of data usage control and digital rights management, which is individual-centered and protects the individual's privacy and gives them control over their data when being shared. So there are some future work to do. And the first one is future research will aim to test the solution usability in a real-world pilot in large-scale software. And we could add use configurable usage controls and in the future. And we could introduce the decentralization of data consumption, which means a kind of decentralized computing environment. And this will be investigated in the future work. And this is the end of this presentation. Thank you for listening.
Very, very nice, Meng. Thank you very much. That was very interesting. Okay, so I'll start with a very basic question that I always ask Perry whenever we're trying to think of stuff to do with blockchain is, do you really need blockchain, or what does blockchain bring to this problem that couldn't have been answered with existing technologies?
Yes, and what I want to do is just want to recall this figure. Think about, we don't have a blockchain here. What kind of information will start? I mean, we need to, for implementing such a system, we need to make the individual register account with the service provider. And in this case, your information will be revealed to any organization. I mean, to the, maybe in our model, it can be data manager, it can be data issuer, it can be, I mean, maybe the consumer, and they will at least get your identity information. But this is the original purpose of this kind of blockchain, the decentralized identity-based blockchain invention. The purpose is to solve the leakage of identity with a blockchain. And in this case, you don't need to register account when you connected to others and share some information with others. For example, when you go to a bar, you need to show your driver license and show you are eligible to buy the alcohol. But in the digital world, with such a solution, you don't need to provide revealed information. What you can do is you can present this information, and the third party will know that this is a valid information, but they do not know the real value. And yeah, I think for the use of blockchain here, it solves the problem of a digital identity and the privacy of this identity.
Because I guess
So here,
when I think of
anything.
sorry, just maybe I misunderstood something, but I guess to me the blockchain provides I guess some consensus layer, right? So that the parties can sort of agree on the state of some piece of data.
I mean,
and
that's back to the very conventional, very beginning. If we don't have blockchain, there is an account, and the account is stored in a centralized database, for example, Google's database. But with a blockchain solution here, I mean, this blockchain, this database is not owned by one party. It's run by several groups. And actually, there's no, there's no are the only owners of this blockchain. So, I mean, they cannot be altered by a single point.
Maybe I could also add, Carlos, that, I know that there's some conversations, for example, like in respect to the use of verifiable credentials and the, in a decentralized European EIDAS framework where, you don't necessarily need to anchor the verifiable credential, the public keys in a blockchain. So you can decide that you can replace the blockchain layer with just a registry. And I know there's conversations about doing that, but where the blockchain comes in is Meng was saying, is that because of, this notion of creating an immutable ledger, that whatever you anchor, in this case, the keys that enable you to authenticate and do the verifiable, to verify claims that are made, like identity claims, for example, in the case of SSI, it makes sure that information can't be manipulated, or it's very difficult to manipulate it, and it's evident when it is manipulated. So it gives you a higher level of assurance about what is the identity information that is anchored into your registry. So yes, it's possible that you don't need to use a blockchain to anchor in, to put in the, the public key information and the schemas that are needed for the verifiable credentials that Meng has included in his solution, and that are typical of SSI-based solutions and verifiable credentials. But that information, then, if it's just in a typical type of registry, a database, centralized database type registry, is subject to some of the same cybersecurity threats that all centralized databases are subject to, and can be more easily manipulated. So you trade off some level of security and information assurance by not anchoring it in a blockchain. That would be my rationale for using blockchain.
But what if we just encrypted everything the same way, but just had everything on the centralized server? Then we couldn't, I guess, manipulate the data.
Well, if it's on a centralized server, though, I mean, at some point, the person who owns who has the decryption keys, the ability to decrypt the secrets on that centralized server, can alter the information that's on that server. So it's fine as long as you trust the entity that is in charge of that centralized database, or that centralized database isn't hacked by some unauthorized actor and access to the secrets isn't breached, but you run that risk, right?
Yeah, so there are many keys involved here, I guess. There's your own key, there's licenser's key, I guess, and the storage key as well. So you're saying if someone steals these storage keys, then they could just hack, they can just open all the secrets.
Well, we're just talking about here the blockchain layer, which is in this case, it's used to set up the peer-to-peer connection, which is set up by the decentralized identities. And in the case of the individual, their public key is not anchored into the blockchain, so it's kind of like a bootstrap of a public key of an issuer, and the holder whose identity can be known. So here we're only concerned with protecting the individual's identity, and the consumer is thought to be an entity whose identity can be known. So the idea here is that the blockchain is used for setting up the connections, and also for the issuance of the verifiable credentials, for verifying identity claims based on verifiable credential. So it's kind of operating as a decentralized PKI, if you will. That's kind of what
the DPKI. I mean, this is called DPKI for this decentralized identity model.
Right.
So maybe it would help if I ask a question about the portion where you actually share the data with the consumer. I think there's a step where the data is decrypted, if I understood correctly. Does that mean
it's decrypted? But that's we leveraged this technology. This is in the field of confidential computing. We call it the fully homomorphic encryption, and you can do computation on the encrypted data. I mean, we decrypted the data, but using the AES encryption, but it's still encrypted in this layer encryption in my solution.
So the consumer never sees the plain text, right? Okay, I see.
Right.
Yeah, because I guess as soon as so the thing that's preventing the double spending of the data is that the consumer never sees the plain text. They can only perform operations on the encrypted data.
Yes.
Right, and that the secret, the encrypted access to the data store is actually time bound. The access link has a time limitation. So they get a certain amount of time that they have access to do their computing, and they never get access to the full.
But can't they just copy the data? Like as soon as they get it, just copy it and then.
And that's why we've kept the data fully encrypted. So if it were the case that they were to copy, the other thing is that they would be entering into we call it a secure enclave. So the idea is that they are given permission to enter into this enclave, and there are restrictions. There would be restrictions in place. You might not be able to. You can compute, but you can't copy. You can't download. Certainly, if you have access and you can view, maybe you can read, but the effort in doing that would be difficult. So the idea is to just make it really, really to discourage someone who is, interested in copying the data for this data double spend, to make it very, very difficult, to create a lot of barriers in the way of doing that. It doesn't prevent a determined actor from using other techniques to replicate and, back engineer. So we've got like a lot of work to do to get to a place where we have a higher level of assurance against the data double spend. But this is our first effort in this area. And, we're starting to think about how can we prevent this problem, which nobody else is really seeming to think about too much. right?
Yeah, and I think
So
there's many
that's what we're trying.
there's many challenges that come with when you're trying to work with blockchain. I think also when you I think this is a problem Perry and I faced a while ago, but the idea of having an
Mhm.
identity in the blockchain is really tricky, right? Because there's no accounts. So, whenever, anybody can just join the network without having, just generating a new public key, depending on the system, I guess, right? But I guess I wonder if you could comment a little more on this idea of being account free, but also having this notion of identity, right?
Well, we're using decentralized identities. So maybe, Meng, do you want to describe how the individual's identities are set up with the DIDs? I think we've got a slide on that. We want to bring the slide back. And this is pretty typical of self-sovereign identity type systems. So the idea is that you don't have one fixed identity. It's not a static identity that attaches as an account or even a fixed identity that links in a static way to me as a natural person or a legal person. I can create a decentralized identity that is static, but kind of like happens with Bitcoin or the best practice in Bitcoin, where for each transaction you are using a new address. And so in the SSI, decentralized identity world, you would have this identity that is dynamic. And that's why individuals in this particular protocol, the Aries Indy protocol, it is not the usual practice to embed the public keys of, so usually you would use two key pairs in PKI. You would not embed my public key into the blockchain, which is meant to be open, a shared database or shared ledger. It's usually the issuer's protocol, and the individual's identity is much more dynamic and sort of bootstrapped on these other public PKIs or public keys that are put into and entered into the registry, which in our case is a blockchain registry. So yeah, this slide explains that a little bit more. And maybe, I don't know, Meng, if you want to describe, how the DID connection is set up between somebody who wants to holds their verifiable credential and wishes to share data with a consumer who's in the role of a verifier in this.
I think that is a part in the paper, but currently it's not in the presentation. Yeah, so I think we can skip this.
Yeah,
part.
it's okay. No, it's okay. I think that was very helpful. I think Perry had a question.
So I think, Carlos, that usually when we were trying to work on these problems, we're thinking of ways, if you want to, instead of giving a credential, if you want to give a demerit to someone, so like some punishment.
Okay.
Well, then if you give some punishment to somebody and they try to, they can just generate a new identity where that punishment vanishes. This is slightly different, where you're giving credentials. So this is these are things you would want to show that you have access to. So
yeah, there's
this
a
is actually where
natural
the problem is
incentive.
different.
Yeah, that's true.
Yeah, this is why it's different than.
Yeah, exactly. This is we don't want it to be known what credentials the individual has. It's for the individual to reveal, that they have that credential, and whatever information is held within that credential. So it is a bit of a different use case from yours. And in this case, we're typically in the pattern that's shown here, the issuer would be sort of, maybe could be a government, an issuer of a government ID, like your driver's license or passport, even a COVID-19, passport, vaccine passport these days. This is the same kind of idea. And some of these passports, COVID-19 passports, are leveraging the same open technology stack that we've used for this solution, which is Hyperledger Indy Aries. And so the idea here would be that that issuer sends me a verifiable credential that contains some data. That data could be anything, but let's say it's a driver's license, it'll contain some standard metadata about me. And then the verifier could be, let's see, you know, I had to show my driver's license the other day with my vaccine passport to get into a restaurant here in Vancouver. We're doing that. So instead of showing my driver's license, I could just I could make a proof presentation, which is based on my verifiable credential, right? So you know, there'll be a QR code, which the verifier scans, and that QR code represents a proof presentation, a claim about me. Hey, I am both vaccinated and I am who I say I am. And that is referencing back to the verifiable credentials that I hold in my digital wallet. There could be two of them, one being the driver's license, one being my vaccine credential. And the proof presentation can rely upon both of those verifiable credentials to make that zero knowledge proof claim. Hey, I'm vaccinated and I am who I say I am. And then the verifier is referencing back to the blockchain to see that that proof presentation is backed by two verifiable credentials signed by, with the public key of the bona fides issuers, the province of British Columbia in both cases, and boom, verified. So that's kind of the basic pattern that we've built on here. And then what Meng has done, he's kind of flipped that. First of all, he's extended it to say, well, it doesn't have to just be identity data. It can be any kind of data. So we can incorporate health data, and that in a sense identifies you. It's just more information about you. And he's flipped the pattern of that is typical of sort of data usage control and licensing, where, you know, we're all used to kind of the large companies. Let's say you buy a digital book, they apply digital rights management so that you have to read that book in their platform, or you can only do so many things with that particular digital, you know, maybe you own it for a period of time, or it's licensed to you for a period of time, and there's controls around it. So we've just sort of flipped that on its head and said, well, let's use those same digital rights management principles to give control to individuals over their data. And then we've used this SSI, open blockchain, trust over IP stack to implement the basic idea. So yeah, but I don't know if that answers your question or if it clarifies things.
Yeah, I think that's
going.
Yeah. I had a broader question. Like, do you guys envision this being, like, let's say in your example of licenses and vaccine passports, do you guys envision the underlying blockchain being like decentralized by a few core nodes, like that are owned by, say, the government of British Columbia and Canada and I don't know, other parts of the world? Or do you envision like a fully decentralized blockchain where anyone can own a node of the blockchain and it's decentralized over the whole world?
I think, well, realistically, it's hard to get to. I mean, the ideal is to have the fully decentralized, owned by the whole world. You know, that gives you, you know, the greatest confidence that what is recorded, you know, depending on how the blockchain, the consensus mechanism works, of course, and that it is a secure consensus mechanism. But let's say we're talking about proof of work for the sake of argument. Okay, well, we know that that's very secure. and it's very difficult to manipulate that. You have to gain, 51% of the, the computing power, you have to be able to control over 51% of the nodes on the network to be able to, brute force have any hope of changing the ledger, let's say. So that level of assurance is the ultimate goal, I guess. And you can achieve that, arguably, you might be able to achieve that through other types of consensus mechanisms, and many different blockchain protocols claim to be able to do that, right? But I think realistically, we have to take baby steps, especially when we're talking about healthcare and health data, which is a very highly sensitive information. If we're talking about people's genetic information, and we need to take baby steps in that direction. So the architecture, the protocol that we've used for this is a private permissioned blockchain protocol. So Indy, the probably the most widely known implementation of the Indy blockchain is like it's associated with the sovereign network, and that's private and permissioned. It's not a big public permissionless protocol. And so I think that, realistically, this is going to be a path of progression, and it's more likely going to be implemented in, it won't be fully decentralized at the beginning. It won't be public and permissionless. It will be private and permissioned, and it'll be operated by some trusted anchor nodes that, might be within the sovereign jurisdiction of Canada, or it might be partners of Canada, or it might be, European Union. There are projects that are going on that are creating these kinds of, data ecosystems within a number of different jurisdictions. And they don't all use this protocol, and they don't all look like this. This is just one implementation, one possible manifestation or configuration of the basic concept that we implemented, because we are trying to explore this idea of how can we prevent this data double spend. I mean, that's the goal of this research. So we're just trying to stimulate people to think about this problem, and think about it think about it and differentiate it from the problem of protecting the data for primary usage, and making sure that we're thinking about in the design of these systems how we also protect the data from these unauthorized secondary uses as well. And it is a difficult problem, going back to Carlos's point. We don't think by any stretch we've solved it. We're just trying to plant a flag and say, this is an important problem to think about. It's different from how we've been thinking about privacy, when it comes to consent of the use of the data for the initial declared purpose. And we need to design for both protecting privacy for primary use and protecting privacy, from these unauthorized secondary uses. So yeah, that's basically the purpose of this research.
I think that sums it up really nicely. I know we have way more questions, but I also know that you both have a meeting coming up next. So unless you have extra time, maybe that's a good place to end it. What do you think?
Yeah,
just trying to be mindful of your time.
Yeah, exactly. I do have a fairly hard stop. So that is a good place to end it, because we're being able to say what the purpose of this research is. I think we have to be quite humble about, this is our first foray into, trying to articulate this question and also trying to solve it. And we look forward to, if anybody who's listening, if both of you have further questions, well, there's a lot more detail in the paper, of course, and lots of references to the Hyperledger Indy Aries protocol that we've used for this particular implementation. And we look forward to receiving your questions, because we would like more people to be thinking about this problem, and we would like to we'd like to be asked those questions so we can improve our research in this area and how we're thinking about this problem. So yeah, thanks for the opportunity to do that and for your great questions.